All right, learning target 12, the last target of the unit, deals with systems. Systems, mainly quadratics, but every now and then there might be a linear involved in the system. But the front page of the notes is dedicated to systems of inequalities, and the back page is systems of equalities. All right, so do you remember graphing last unit? Inequalities, solid, dotted, shade above, shade below, that kind of stuff. Same thing here. I technically could have probably broken this apart into 2 different or even 3 different targets, but I just didn't feel the need to. Because number 1, when you graph number 1, remember back to the last unit, greater than or equal to, you would have graphed a solid line and you would have shaded above. Same thing here with a parabola. It's just not a line. Graph a solid parabola, shade above. Now, when we move into the system part, there's just going to be 2 inequalities instead of 1. All right, so, but now, the graphing, you can use your calculator to get the points that I did in number 1, or you can do this. All right, listen carefully. This is for the more advanced. If you want to save you a few extra seconds, when it's in vertex form, like number 2 and number 3, you can do something different to graph. Remember those words, left 3, up 4, right 2, down 5, and then reflect it over the x? Those will help you graph a lot faster than the calculator. Example, well, number 1's not in vertex form, so let's skip it. Let's go to number 2. The h is negative 3 in number 2, and the k is 4. So you would have said left 3, left 3, down 4. Agreed? That's why the vertex, negative 3, negative 4, is in the middle of the table already. But what points are you moving? You're moving the points of y equals x squared. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, square the x. If the a is 1, like it is in all of these, there's no stretching or compressing. No stretching or compressing. So you can literally move the vertex and then graph the points 1, 1, 2, 4, 3, 9, etc. Let me do the picture part first. If you move number 2's vertex to negative 3, negative 4, left 3, down 4, your new vertex is right there. Oh, the screen is frozen? Yeah, butchered that one. You've just now moved the vertex that was at 0, 0 to this new point. So you can use it to graph the following points. From our new vertex, graph 1, 1, 2, 4, and 3, 9. 1, 1 would mean go right 1, up 1. 2, 4, right 2 from that vertex and up 4. 3, 9, right 3, up 9. So 5, 6, 7, 8, 9. And those would translate into these ordered pairs. Negative 3, 0, and up 5 more, 0, 5. I personally don't list the table values. I just move the vertex and then go right 1, up 1, right 2, up 4, right 3, up 9, etc. What's your other option again? Before you forget, the other option is type it in your calculator and go to your own table and pull the points out that you need to graph. That will work just fine. All right? But symmetry says the same points will be on the left. So you can graph a little bit faster maybe with that method. Number 3, the a is negative 1. So something a little different changes. A is negative 1. In number 3, your vertex moves right 1, up 7. And then instead of graphing 1, 1, 2, 4, 3, 9, it's going to flip upside down. So when you go right 1, go down 1. When you go right 2, go down 4. Then right 3, down 9, which would translate into the ordered pairs 2, 6, 3, 3, and 4, negative 2. And of course, symmetry says we have the same thing on the left side. All right, so the same table values on the left side. The same table values over here in number 2 on the left side. But again, your other option, just graph it in the calculator and go to your table and pull the points out that way. Yes. HK. The starting point, HK. in number 3, the H is 1 and the K is 7. That's learning target 7, or the one we just reviewed in the bell work, learning target 11. So your vertex is 1, 7. All right, finish it off. Back from the last unit, number 1 would be solid, shade above. Number 2 is less than, so it would be dotted, shade below. And number 3 would be, again, dotted, shade below. All right, so put it all together. Number 1, we got our points graphed. It's solid. And shade above, which would be inside of the parabola. Number 2, is that green, number 2? Red? No, doesn't matter. Number 2, dotted, shade below, which would be not inside the parabola, outside of it. And then number 3, again dotted. Shade below, so this time it would be inside of the parabola. All right, I made a typo on your notes. Change these to 3 3s right here and right here. And change this to 4 4. That's enough to illustrate what I was trying to illustrate. Okay. Number 1, in the blue graph, does 3 3 work? Does 3 3 work? Is it in the shaded region? Okay, so yes. What about 4 4? And why is it special? 4 4. 4 4 is right there. It's on the line. Does it work? Yes, because it's solid. Remember that. Solid meant it's shaded. Solid meant that the line itself is shaded. So yes, it does work. And the next one, 3 2. Yeah, it's definitely in the shaded. 2 4. Yep, definitely in the shaded. What about 3 3 in graph number 3? What's special about it? 3 3 is right there. It's on the line. It's on the boundary. But it's dotted, so it's not included. So no. 2 4. Right 2 up 4. Yeah, right there. Yep, it's in the shaded. All right, so then that was the prerequisite, and I could have probably made that a target, but the next one, systems of inequalities, is literally just going to take 2 of those and graph them on the same graph, and just like in linear inequalities, we're looking for where they overlap. So 2 parabolas, 2 shadings, where do they overlap? Number 4 and number 5. Number 4. Number 4 is going to be solid, and it's going to be shade below. I'll do this one in blue. And the second one is going to be solid. I'll use red for this one, and it's going to be shade above. All right, so when you're doing these kind of problems, homework, these are in vertex form. I made sure that all of your homework questions are in vertex form. So you can use the little shortcut as long as you feel comfortable with it. To graph the blue one, what's your vertex? -3, +4. So left 3, up 1, 2, 3, 4. And your A is a negative. So instead of going right 1, up 1, go right 1, down 1. Right 2, down 4. Right 3, down 5, or down 9. What would be the next point? After 3, 9 would be 4, 16. I think it runs off the page where you can't fit it. 10, 11, 12, 13, 14. Yeah, it runs off the page. Symmetry says you'd have the same on the other side. I'll go ahead and do solid, but I won't shade because I would have to erase a little bit. Shade below. So it's going to be inside the blue parabola. Now switch to red. What's the vertex for x squared minus 5? What's the h? 0. And the k? -5. So 0, -5 is the red. It's right where you already put a point. At 0, -5. And it's an a value of 1. So we will go right 1 up 1, right 2 up 4. And then right 3 up 9. Symmetry on the other side. And you'll notice that you're graphing a red point on the vertex of the other parabola. Again, solid. 10, 11, 12, 13, 14, 15. I think 16 almost fits, so I'll go ahead and put it up here. 16 is just the right 4 up 16. It almost fits on the picture. And then we think a little bit. We're going to shade above that red one, so we're going to shade inside of that red parabola as well. So if we're shading inside the blue and inside the red, where do they overlap? In that little middle part, so your final shading would go right in here. That's the solution to this system of inequalities. So there's a couple of interpretive questions at the bottom. Which of these following 4 points satisfy the system? 0, 0, does it work for both inequalities? No, it works for the red one. It's in the red inequality, but it's not in the blue. It's not where they overlap. So nope, not that one. What about -1, -2? Yeah, that one's in there. -3, +4. What's special about that point? It's right here where they intersect. So does it work? They're both solid lines, so yeah. They're both solid lines, solid parabolas, so yeah. 0, -5, again, same thing. 0, -5 is where they intersect. And they're both solid, so yes, it works. I know, pause the video. You try number 4. Try number 4, and then you can check it. It's really the shading in number 4 that I'm worried about, not so much the parabolas themselves. But before you start it on your own, at least let's do this part together. Solid, dotted, above or below. In the first one, dotted, shade, y is greater than, shade, above. In the second one, yep, solid, shade, above. All right, so I'll pause the video, try it. So now we've got those two boundaries graphed, the red one and the blue one, either by using the 1, 1, 2, 4, 3, 9 graphing method or going to the table. But now it's shading time. The blue said shade above, so you're going to shade inside of the parabola that's blue, right? So let me number those. Let me number those options. Option 1, that's a big 1, so I can try to make it spill over the x or over the y-axis. Option 2, in here. That's the only 2 options you have for shading. Inside of the blue dotted parabola. Now, which one is it? 1 or 2? Well, the red says also shade above. So it's the option number 1. You will shade in here. Above the red and above the blue, which is inside of the blue. And I'll erase the other 2 there. All right, and then the interpretive questions. Circle the points that satisfy. First one, 0, 0. Does that one work? Nope. 1, 7. Yeah, that's high enough to get into there, into the shaded region. What about 0, 6? Well, what's special about 0, 6 for starters? 0, 6 is the vertex of the red parabola. It's on that line, but it's solid, so yeah. Now I've got, in quotes, intersection points because I didn't want to mess around and try to find those decimals just yet. But they're crossing somewhere. I can't tell from the graph where, but they're decimals. Are the intersection points part of the solution, though? No, yeah, so you're shaking your head no's. Why? One of them is dotted, which means that any point on the blue line, blue parabola, doesn't work. So this point here and this one here, the intersection points, they don't work in both. They only work in the red, not in the blue. All right, I'm going to stop the video there as part one. And you're going to have a decision right now whether we stop, pause for a couple of minutes, really, because we're running out of time, or move on to part two.